In logic, necessity and sufficiency are implicational relationships between statements. The assertion that one statement is a necessary and sufficient condition of another means that the former statement is true if and only if the latter is true. That is, the two statements must be either simultaneously true or simultaneously false. In ordinary English, necessary and sufficient indicate relations between conditions or states of affairs, not statements. Being a male sibling is a necessary and sufficient condition for being a brother. Fred's being a male sibling is necessary and sufficient for the truth of the statement that Fred is a brother. Definitions: a true necessary condition in a conditional statement makes the statement true. In formal terms, a consequent n is a necessary condition for an antecedent s. In the conditional statement, n if s, n is implied by s, or ns. In common words, we would also say n is weaker than s, or s cannot occur without n. For example, it is necessary to be named, to be called Socrates. A true sufficient condition in a conditional statement ties the statement's truth to its consequent. In formal terms, an antecedent s is a sufficient condition for a consequent n. In the conditional statement, if s, then n, s implies n, or sn. In common words, we would also say s is stronger than n, or s guarantees n. For example, Socrates suffices for a name. A necessary and sufficient condition requires both of these implications to hold. Using the previous statement, this is expressed as s is necessary and sufficient for n, s if and only if n, or sn. Necessity. The assertion that Q is necessary for P is colloquially equivalent to P cannot be true unless Q is true, or if Q is false then P is false. By contraposition, this is the same thing as, whenever P is true, so is Q. The logical relation between them is expressed as if P then Q, and denoted PQ, and may also be expressed as any of Q, if P. Q whenever P. And Q when P. One often finds, in mathematical prose for instance, several necessary conditions that, taken together, constitute a sufficient condition, as shown in example 5. Example 1, in order for it to be true that John is a bachelor, it is necessary that it be also true that he is, unmarried, male, adult. Since to state John is a bachelor implies John has each of those three additional predicates. Example 2, for the whole numbers greater than 2, being odd is necessary to being prime, since 2 is the only whole number that is both even and prime. Example 3, consider thunder, the sound caused by lightning. We say that thunder is necessary for lightning, since lightning never occurs without thunder. Whenever there's lightning, there's thunder. The thunder does not cause the lightning, but because lightning always comes with thunder, we say that thunder is necessary for lightning. Example 4, being at least 30 years old is necessary for serving in the U.S. Senate. If you are under 30 years old then it is impossible for you to be a senator. That is, if you are a senator, it follows that you are at least 30 years old. Example 5, in algebra, in order for some set S together with an operation to form a group, it is necessary that be associative. It is also necessary that S include a special element E such that for every X in S it is the case that EX and XE both equal X. It is also necessary that for every X in S there exist a corresponding element X such that both XX and XX equal the special element E. None of these three necessary conditions by itself is sufficient, but the conjunction of the three is. Sufficiency. To say that P is sufficient for Q is to say that, in and of itself, knowing P to be true is adequate grounds to conclude that Q is true. The logical relation is expressed as if P then Q, or PQ, and may also be expressed as P implies Q. Several sufficient conditions may, taken together, constitute a single necessary condition, as illustrated in example 5. Example 1, stating that John is a bachelor implies that John is male. So knowing that it is true that John is a bachelor is sufficient to know that he is a male. Example 2, a numbers being divisible by 4 is sufficient for its being even, but being divisible by 2 is both sufficient and necessary. Example 3, an occurrence of thunder is a sufficient condition for the occurrence of lightning in the sense that hearing thunder, and unambiguously recognizing it as such, justifies concluding that there has been a lightning bolt. Example 4, a U.S. president signing a bill that Congress passed is sufficient to make the bill law. Note that the case whereby the president did not sign the bill, for example through exercising a presidential veto, does not mean that the bill has not become law. Example 5, that the center of a playing card should be marked with a single large spade is sufficient for the card to be an ace. 3 other sufficient conditions are that the center of the card be marked with a diamond, heart, or club, respectively. None of these conditions is necessary to the cards being an ace, but their disjunction is, since no card can be an ace without fulfilling at least one of the conditions. Relationship between necessity and sufficiency. A condition can be either necessary or sufficient without being the other. For instance, being a mammal is necessary but not sufficient to being human, and that a number is rational is sufficient but not necessary to s being a real number. A condition can be both necessary and sufficient. For example, at present, today is the 4th of July is a necessary and sufficient condition for today is Independence Day in the United States. Similarly, a necessary and sufficient condition for invertibility of a matrix M is that M has a non-zero determinant. Mathematically speaking, necessity and sufficiency are dual to one another. For any statements S and N, the assertion that N is necessary for S is equivalent to the assertion that S is sufficient for N. Another facet of this duality is that, as illustrated above, conjunctions of necessary conditions may achieve sufficiency, while disjunctions of sufficient conditions may achieve necessity. For a third facet, identify every mathematical predicate N with the set T, N, of objects, events, or statements for which N holds true. Then asserting the necessity of N for S is equivalent to claiming that T, N, is a superset of T, S, while asserting the sufficiency of S for N is equivalent to claiming that T, S, is a subset of T, N. Simultaneous necessity and sufficiency. To say that P is necessary and sufficient for Q is to say two things, that P is necessary for Q and that P is sufficient for Q. Of course, it may instead be understood to say a different two things, namely that each of P and Q is necessary for the other. And it may be understood in a third equivalent way, as saying that each is sufficient for the other. One may summarize an I-euro, and thus L-euro of these cases by the statement P if and only if Q, which is denoted by PQ. For example, in graph theory a graph G is called bipartite if it is possible to assign to each of its vertices the color black or white in such a way that every edge of G has one endpoint of each color. And for any graph to be bipartite, it is a necessary and sufficient condition that it contain no odd-length cycles. Thus, discovering whether a graph has any odd cycles tells one whether it is bipartite and vice versa. A philosopher might characterize this state of affairs thus: although the concepts of bipartiteness and absence of odd cycles differ in intention, they have identical extension. If P is necessary and sufficient for Q, then Q is necessary and sufficient for P, because necessity of one for the other is equivalent to sufficiency of the other for the first one. Both of these statements are equivalent to both of the statements P is true if and only if Q is true, and Q is true if and only if P is true. See also, causality, material implication, Wasson selection task, closed concept. Argument forms involving necessary and sufficient conditions equals. Valid forms of argument, modus ponens, modus tollens. Invalid forms of argument, affirming the consequent, denying the antecedent. References. External links, Critical Thinking Web Tutorial, Necessary and Sufficient Conditions, Simon Fraser University, Concepts with Examples.